Okay, I'm going to do some of the moments at about A. I'm going to say this way is positive for now. So you get minus 6 times 3 minus 8 times 7 RB times 5. Reaction at B should equal 1856 74 divided by 5. What?
14.8.
14.8. Told you so. Kill Newtons. Okay, remember, if you ever get a negative number when solving the free body diagram, all it means is your arrows need to point in the other direction. Okay? Some of the forces in the y equals 0. You got minus 6, minus 8, plus RA, and then plus 14.8. Reaction at A equals, oh, convenient. Negative 0.8, right?
Mm-hmm.
So that means all it means is RA is actually going down at a value of 0.8. Let's just do that. Okay? All right. Let's get to the good stuff. Okay? It's a pin. We've calculated there's an initial force. I'm going to go ahead and say if the force is pushing up this way, it's going to be positive. So that's 0.8. This is negative 5.2. And then, am I doing this right?
This would be negative. First one's negative.
Jeez, calm down, man. Be so mean. That's 2.8. 6. So that's 5.2.
No.
What? Oh yeah. I forgot. I'm tripping, man. I'm tripping. 6.8. There, now the numbers work out. Okay. Slide this down a little bit. B, this moment. It's not a wall, so there's no initial moment. So you start at 0. Okay. If I have negative numbers here, I'm just going to go in the negative direction for a negative slope. Boom. Okay. 0.8 is pretty close to 0, so it's pretty flat, but it's still in the negative direction. 6.8 will be a lot steeper. And then positive 8 the rest of the way. Okay. If you want to find these points, you can just figure out the areas. So 0.8 times 3, you get negative 2.4. You add on another 2 times 6.8, so that's 13.6 plus this. Get you 16. And then 2 times 8 will get you positive 16, and you come all the way back to 0. Any questions on how I do these? All right. Let's write these equations. From 0 to 3, the shears are pretty easy. There's this value. 0.8. Okay. There's no slope in these, so there's not going to be an x component. From 3, 5. 6.8. And then from 5 to 7. You got All right. Moment equals integral v. Okay, this is how I like to do it. So let's go ahead and do the first one. Different color. Moment. Okay. If you integrate a constant, you just tag on an x. Okay, and then whenever you integrate something, you have an unknown constant. Okay, I'm going to go through all of them first, and then we'll figure out the constants. X equals 2. Okay, so if you take a look here, the moment equations take the form of y-intercept form. So one way you can find the constants is to see where the line crosses the y-axis. Okay, so you have this first line, it crosses the y-axis at 0. So you know C1 is equal to 0. The second line, you would have to follow the slope all the way up, and the y-axis, it would cross the y-axis somewhere up here, and then similarly, this last line, it would cross the y-axis all at the bottom. Another way you can do it is just plug in values that you know. So going on the first one, I told you that at x equals 0, you know the moment equals 0. If you plug in 0 for x, your equation should equal 0, so that means C1 has to equal 0. So the moment equation for this first piece will just simply be negative 0.8x. Okay? The second one. If you don't know these points for some reason, like if you didn't do it by finding the area, you could just plug in 3 here. That'll get you this point at 3, and you'll know it's negative 2.4. When you come to this equation, you know at x equals 3, it's got to equal negative 2.4, and then you find your C2 from there. Okay? Similarly with C3. All right? I'm not going to go through and solve them, but all you have to do is plug in an initial condition or a boundary condition, and then you should be set. Any questions on how to do this? All right? Like I said, if you can do this right, you should be in good shape for Chapter 9. But most of you can't do this right, so you guys are in bad shape for Chapter 9. Honestly, this is just one of those practice things. Okay? A lot of you guys understand that m is the integral of v. You guys understand how to draw this, but you can't draw it to this. Okay? Just go through the textbook, find different problems with walls, pins, distributed loads, and just go through a practice, or go on Chegg and just look on the answer key and kind of understand what they're doing. I'm not saying, I endorse Chegg, but who's going to tell me they don't use it? Come on. All right. So let's do this one. Okay. If you guys run into a problem like this on the exam, the first thing you should do is close your eyes and take a deep breath, okay? Just because there's variables doesn't mean you start freaking out. Like, oh my goodness, there's no numbers, I don't know what to do. You do the same thing, it's just a lot messier, so just keep your work organized. All right? I'm going to draw an equivalent. Equivalent loads first, so I can find out the reactions. Okay, remember, for a flat line distributed load, the equivalent load happens right at the middle, right? So if this distributed load goes over the distance of L, the equivalent load will happen at half of L. So let's go ahead and do that. This will be WL. This will be WL as well. Okay? Sum of moments at A equals 0. Okay? The equivalent loads are just equal to the values times the distance, right? W times L, 2W times L over 2. The 2's cancel out. So they're the same. Sum of moments. Once again, I'm going to do this. Start with negative WL, that's the force. Okay, times the distance. I said it was L over 2. Okay, let's do this force. We get WL. And the distance is L plus half of L over 2, so it's L over 4th plus 1, so 5/4 L. So you're left with reaction B, L equals WL squared over 2 plus WL squared 5/4. L's will cancel out. I'm going to add these up. RB equals 7/4 L. Yeah. And then the reaction at A, you just do sum the forces in the Y equals 0. So you got negative WL, negative WL, 7/4. Reaction at A, that all equals 0. You know the reaction at A equals 1/4 WL. Good with these values? All right. Shear moment diagram. Okay, when you guys go to draw the shear moment diagram, you have to go back to the original loads, not the equivalent ones. Okay. So I'm gonna redraw this really quick. Okay, once again, I'm going to make this way positive for my shear. This is going to be 1/4. It's going to start at 1/4 right here. Okay, and then it's going to decay at a rate of W for a distance of L. So you should go like right. You should be at negative 3/4 WL. Okay. It gets pushed up 7/4. So you're up at a whole WL, right? Just 4/4. 4/4 factored to 1. And then it comes down at a rate of 2W over the distance of L over 2. 2W times L over 2. Okay, WL here, it drops down WL, you should end up at 0. Boom. Okay, that's here. All right, moment. You know there's no initial moment because there's no wall, there's no moment being applied, so your initial moment is 0. Starts at a positive slope temporarily, and then it starts to get more and more negative. So, I don't know. Boom. Yeah, it should get steeper as you go. And then it concaves up. Remember, as the shear value approaches 0, your moment line flattens out. Okay, so it jumps up to positive, and then as it approaches 0, it flattens out, so it should look something like that. Give or take. Okay? If you wanted to find, the area under this curve, the height of this curve right here, that's equivalent to this little area. The minimum down here is equivalent to this area minus this area. And then that takes you away up. Okay? So let's write the equations for this. I'm not going to write the maximum and minimums. Let's just do it straight up. So, when x is between, I'm going to call this last part C. And I'll call this middle part D. Okay? Oh, yeah, we don't even need that middle part. Doesn't matter. Go back to the original graph. From A to B. A to B. This is shear. Okay? It's all one slope, it's all one line, so it all goes in one equation. Okay? For every different line, there should be a different equation, right? These could have the same slope, but they're two different equations because they're two different lines. They would run into the y-intercept at different spots, so you'd have to write two different equations, right? So from A to B, V equals, what's the slope? Negative W, X. I'm going to put C for now. Okay. And then, right over here, from B, C, V equals negative 2WX plus C2. All right, so C1, okay. You know at x equals 0, your shear should be 1/4 WL, okay? So if you were to plug in 0, you should get 1/4 WL. So C1 has to equal 1/4 WL.
Shouldn't that slope be W over L?
Where?
Isn't W the total? And W over L would be the distributed.
The slope?
Yeah.
The slope is these values. L is the distance the slope travels. So, I don't know how to explain it. You wouldn't put W over L because you would be left with a force over distance divided by the distance, right? So you would be left with the force, and then you're multiplying by another distance again, so your units wouldn't be in force anymore. Does that make sense, right? So if you were to do what you said, W over L, X, right, your units would be, for example, pounds per foot divided by feet times feet. Okay, these would cancel out, and then your shear force would be in units of pounds per foot, which isn't correct. It should be in pounds, right? So that's one way you can check to make sure if your variables are right. But I kind of how do I explain it? Here it's W times L because these are values. But how do you find a slope, right? It's the difference between is what you subtract delta y over delta x. Okay, you would subtract one another and then divide by the delta x, which would be L. Delta x for these 2 points is the distance of L, so that would get rid of your L's. Does that make sense? So, you know, C1 here is equal to 1/4 WL. And then here, you know at x equals 5/4 L, you should be at 0 again. So if you were to plug in 5/4 L, you should be left with 0. So negative 2W 5/4 L plus C2 equals 0. C2 equals 5/2 WL. Positive. Any questions on any of this stuff? Okay. Remember, I'm going to highlight this now and then I'll explain to you why in a bit. This used to be a constant, and this used to be a constant. Just remember that, and then we'll get back to you later. All right. Moments. Once again, it's just the integral. So negative wx squared over 2. That's a constant, so you just tag on an x. Okay. Plus, we'll call this one C1. Moment equals negative 2, nope, it'd be